Alright, this is lesson 1.3 in variables and patterns. We're going to look at how to read and analyze a graph, specifically a coordinate graph. So we're going to tell the story behind some graphs that we're going to look at today. Alright, so let's jump right in. So we're going to look at the idea of a long distance bike ride. So John is riding his bike from Atlantic City to Cape May. He recorded the distance he traveled every half hour during his trip and put the data in the table below. So we're going to make a coordinate graph of the table. So let's take a look. We have the Atlantic City to Cape May. We have time going down here. Looks like it's going up every half hour. Then we have distance in miles going up randomly. Alright, first part about the coordinate graph is the title. Let's steal the title from the table. So Atlantic City to Cape May. So AC to, and it's not letting me write it, Atlantic City to Cape May. I don't know why it's doing that, but Atlantic City to Cape May. And on the bottom is always time. So on the side, this time is distance. Now, over here, we have time counting up by every half hour to get to 5. So I'm going to count up by the same thing. 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. Perfect. Distance needs to go from 0 up to 45. That's not even close to 100, so I'm just going to count it by 5s. So we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 45 is the highest we need to go, so that's good. Alright, let's go ahead and start graph the coordinates. At 0 time, we have 0 miles, because he has not started yet. 0.5, we're at 8, so probably right about there. At 1, we're at 15. 1.5 is at 19. 2 is at 25. 2.5 is at 27. 3 is at 34. 3.5 is at 40. 4 is at 40. 4.5 is at 40, and 5 is at 45. Let's connect all these with the line segment. And now we have our coordinate graph finished. So we're going to use this now and read it to answer a couple questions. Alright, so we're going to analyze the graph. What is the coordinate pair for the third point from the left? Third point from the left. So let's take a look. 1, 2, 3. The coordinate pair is that at 1 hour, we're at 15 miles. So the way we write this is in parentheses 1, comma, 15. What do you think happened from hours 3.5 to 4.5? So let's take a look. From 3.5 to 4.5. We have a flat graph, and if you remember from lesson 1.2, a flat graph means nothing happened. So they must have stopped. Since you know they're talking about a bike ride, come up with the reason why they stopped. So I'm just going to say maybe they stopped for lunch. You can come up with whatever reason you would like, but something has to say that they stopped. Alright, that's pretty simple. Let's move on to the back. Oh, nope, the bottom of the front page, sorry. Tell what may have happened in the following graph pieces. So let's say our graph looked like these pieces, in the sense that they're still on a bike ride. So on this first one, it looks pretty steep, and then gets shallower and shallower. Well, if you remember right, the steeper the graph is, the faster they are. So they start out really fast, and then it looks like they slow down. So started fast, then slowed down. Over here, looks like we have the opposite. Looks like they start out slow and then they go faster, 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 faster. So started slow, then went faster. Down here we have flat, which means they did not go anywhere, and then they went fast. So it looks like they sat still for a bit, then went fast. So sat still, then went fast. Over here looks like we have the opposite. They went fast and then they sat still. So went fast, then sat still. We don't know if this is exactly what happened, but it's good to have a general idea about how to read a graph. Alright, now we're moving on to the back. Practice problem, basically doing the same thing. Katrina's parents kept this record of her growth from her birth until her 18th birthday. Make a coordinate graph of the table below. Katrina's height. So, Katrina's height. We have time. Looks like that should be years. Time in years. So time on the bottom. And then height on the side. Alright. All that has been copied over. Now let's look at our scale. We start at 0 on both. Time, looks like we have to go all the way up to 18. We're not going to get to 18 if we count by 1, so I'm going to count by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 is higher, that's okay. Height, we have to go all the way up to 65. If you're higher than 60, you might want to, or if you're higher than 50, you might want to count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. This is as high as we need to go, so that's okay. Let's go ahead and graph it. At 0 years, Katrina is 20 inches tall, which makes sense. A baby does not start out at 0 inches long. When they are born, they're about a couple feet long, so 20 inches works. So at 0 years, we're at 20. At 1 year, which is between here, we're at 29. 2 is 33. 3 is 37. 4 is 39. 5 is 42. 6 is 46. 7 is 48. Oops, sorry, 47. 8 is 49. 9 is 52. 10 is 54. 11 is 57. 12 is 59. 13 is 61. 14 is 64. 15 is 64. Remember, if it's flat, it means nothing happened. She must not have grown. 16, still 64. 17, 65. And 18, 65. So let's go ahead and connect these. And then we have our coordinate graph. So let's go ahead and answer some questions on this. During which age did Katrina grow the most? Remember, if you're looking at for the fastest or the slowest speed, we have to look and see what we are adding by here and find the fastest. So 20 to 29 is 9, 4, 4, 2, 3, 4, 1, 2, 3, 2, 3, 2, 2, 3, 0, 0, 1, 1. So we were looking for growing the most. So the highest number here is 9. So it looks like from 0 to 1 years old, she grew the most. So from 0 to 1, she grew the most. During which age did Katrina grow the least? So that's the opposite of the most. What is the smallest number here? Looks like we have a 0, a 0. Oh, this is supposed to be 0. So didn't grow, didn't grow, didn't grow. We have a couple different spots. So we have 2 zeros, so from 14 to 16, and then again from 17 to 18. So from 14 to 16 and 17 to 18, she did not grow. Is it easier for you to use the table or the graph to answer questions number 1 and number 2? Should be number 2 and number 3. And why? Well, this is your personal preference. For me, I wanted to look at the table. That's why I did this, because you can see exactly. If you're looking at the graph, to me, it's not as exact. I want to see the exact numbers so that I can add everything up and tell from that way, but it's up to you. I'm going to say the table. So it's easier to use the table because you can see the numbers. Okay. All right, looks like the last question we have, so let's go back to the start. Just review it all, make sure we have it all done. So we wanted to look at how to read and analyze a graph. So we're going to tell a story behind a graph. We looked at this Atlantic City to Cape May scenario. We graphed the table. We analyzed the graph. We picked a coordinate pair. We explained what we think might have happened during the ride. We came up with some example explanations for these various graph shapes. Then we graphed Katrina's height using this table into this coordinate graph, and then answered a few questions about it. So that wraps up lesson 1.3. Next up is lesson 1.4, and still in variables and patterns.